Why is there a place on Earth where nothing can live? There are places on Earth where nature appears almost impossible. Places where temperatures become unbearable, where the ground releases poisonous gases, where storms reshape entire landscapes. But there is another kind of place that is even more disturbing, a place where the problem is not fire, not ice, not a violent storm. The problem is something invisible, a place where the water looks normal. The ocean appears calm, but beneath the surface, almost nothing is alive. No fish, no crabs, no plants, no complex ecosystem. Only a silent underwater desert stretching across thousands of square kilometers. Scientists call these areas dead zones, and they represent one of the strangest environmental mysteries on our planet. Because the ocean is usually considered one of the greatest sources of life on Earth. It covers more than 70% of the planet. It produces a significant amount of the oxygen we breathe. It supports millions of species, from enormous whales traveling across entire oceans to microscopic organisms invisible to the human eye. The sea is alive. But in certain places, that life disappears. How can an environment that normally supports so much biodiversity suddenly become almost empty? The answer begins with something every living creature needs: oxygen. On land, we rarely think about oxygen disappearing. The atmosphere constantly surrounds us. Every breath provides what our bodies require. But underwater, oxygen is not unlimited. It must be constantly replenished. Waves mix oxygen from the atmosphere into the upper ocean. Currents move oxygen-rich water around the planet. Tiny plants called phytoplankton produce oxygen through photosynthesis. This delicate balance allows marine ecosystems to survive. But when that balance breaks, something extraordinary happens. The ocean begins to suffocate. A dead zone is an area where oxygen levels become so low that many marine animals cannot survive. The scientific term for this condition is hypoxia. When oxygen falls below a certain level, fish begin searching for better conditions. Some escape, some struggle, and some simply cannot survive. The result is an underwater landscape that feels almost impossible. A place filled with water, but without the life that should exist inside it. One of the most famous examples appears every year in the Gulf of Mexico. Near the coast of Louisiana and Texas, a massive dead zone forms where the Mississippi River meets the ocean. At its largest, this area can cover thousands of square kilometers, an area larger than many cities. From above, everything looks normal. The waves continue moving, ships continue crossing, the sun continues shining. But beneath the surface, the story is completely different. The ocean floor becomes a place where many animals cannot breathe. So how does this happen? The answer begins far away from the ocean. Hundreds or even thousands of kilometers inland, farms use fertilizers to help crops grow. These fertilizers contain nutrients such as nitrogen and phosphorus. They are essential for agriculture. They help produce the food that feeds billions of people. But when heavy rain washes these nutrients into rivers, they begin a chain reaction. The rivers carry them toward the sea, and eventually, they reach the ocean. At first, the extra nutrients seem harmless. In fact, they create something that appears positive, an explosion of life. Tiny organisms called algae begin multiplying rapidly. The water becomes filled with enormous algae blooms. From the surface, this may look like a sign of a productive ecosystem. More plants, more food, more life. But the reality is far more complicated. When the algae die, they sink toward the ocean floor. There, bacteria begin breaking them down. During this process, the bacteria consume enormous amounts of oxygen. The deeper the dead algae accumulate, the more oxygen disappears. Eventually, the water becomes so depleted that larger organisms can no longer survive. A place that once supported countless creatures becomes a biological desert. The strange part is that this process happens almost silently. There is no explosion, no dramatic warning, no visible destruction. The ocean simply loses its ability to support life. And because these changes happen underwater, humans often do not see them until the damage is already widespread. For fishermen, the effects can be devastating. A region that once provided abundant catches can suddenly become far less productive. Marine animals are forced to move. Food chains are disrupted. Entire ecosystems are placed under stress. And scientists have discovered that dead zones are not only increasing in size, they are appearing in more locations around the world. From coastal waters near Europe, to areas surrounding Asia, to enclosed seas with limited circulation, the pattern is becoming impossible to ignore. But human activity is not the only force capable of creating places where life struggles. Nature itself has created some of the most extreme environments on Earth, places where even the toughest organisms must fight to survive. A volcanic landscape in Ethiopia, where the ground is covered with salt and acid pools. A lake in Tanzania, where animals can become preserved by mineral-rich waters. A desert so dry that some regions may not have received rain for hundreds of years. These locations remind us of something important. Earth is not automatically designed for life everywhere. Life exists because conditions are balanced. Temperature, water, chemistry, energy. When even one part of that balance changes, the result can be dramatic. The dead zones beneath the ocean are not empty because life is weak. They are empty because the environment has crossed a limit where survival becomes almost impossible. And scientists are now asking a much larger question. If human activity can create small dead zones in the ocean today, could the same process create much larger changes in the future? Could entire regions of the sea become uninhabitable? And what does that reveal about the fragile balance that allows our planet to remain alive? The idea of a place where nothing can survive sounds impossible. After all, life has proven itself to be incredibly resilient. It exists in boiling waters near underwater volcanoes. It survives beneath kilometers of ice. It lives in environments once considered completely impossible. Scientists have discovered organisms that can survive extreme heat, intense pressure, toxic chemicals, and conditions that would destroy most forms of life. So perhaps the real mystery is not that some places become hostile. The real mystery is how life manages to survive at all. One of the most extreme examples can be found in Ethiopia's Danakil Depression. Located in one of the hottest regions on Earth, this landscape almost looks like another planet. The ground is covered with bright yellow sulfur fields. Salt formations stretch across the horizon. Pools of acidic water release toxic gases into the air. Temperatures regularly climb above 40 degrees Celsius. The environment appears completely lifeless. Yet even here, scientists have discovered microorganisms capable of surviving conditions that challenge our understanding of biology. These tiny organisms are called extremophiles. They are living proof that life can adapt in ways humans never imagined. They do not need comfortable conditions. They do not need sunlight. They do not need environments that seem welcoming. They simply need the right combination of chemistry and energy. Another strange location is Lake Natron in Tanzania. From a distance, it can look beautiful. The water may appear bright red or orange, creating a landscape that seems almost artificial. But this lake has one of the most unusual chemical environments on Earth. Its water is extremely alkaline, with mineral levels high enough to create a hostile environment for many animals. The lake can reach temperatures that make survival difficult. Its chemistry is so unusual that animals that die there can become naturally preserved by mineral deposits. For years, photographs of preserved birds created the impression of a deadly lake, where anything that touched the water instantly turned to stone. The reality is more complicated. Many animals do survive around Lake Natron. Some species have adapted specifically to its extreme conditions. Flamingos, for example, depend on the lake as an important breeding location. Their specialized biology allows them to survive where many other creatures cannot. Once again, the lesson is not that life disappears everywhere. The lesson is that life changes, it adapts, it finds opportunities in places we would never expect. Then there is the Atacama Desert in Chile, one of the driest places on Earth. Some regions have experienced almost no rainfall for centuries. The landscape is so dry that NASA has used parts of the Atacama to test technology designed for Mars missions. The soil resembles what scientists expect to find on other planets. The sky is so clear that some of the world's most advanced telescopes operate there, searching deep into the universe. At first glance, the Atacama appears completely empty, but even there, life exists. Tiny microorganisms survive hidden beneath the surface. Specialized plants capture rare moisture from fog. Animals have evolved to survive with almost no water. The desert is not dead. It is simply living at the edge of possibility. And this brings us back to the ocean. Because the existence of extreme environments teaches scientists something important. Life is not as fragile as we once believed, but ecosystems are. A single organism may survive incredible challenges. An entire ecosystem is far more delicate. A dead zone does not mean that every living thing disappears forever. Instead, it means the balance that supports complex life has been disrupted. Some species escape, some adapt, some vanish. And when one part of the food chain changes, the effects can spread outward. Small organisms affect larger organisms. Larger organisms affect predators. Predators affect the entire ecosystem. Everything is connected. This is why scientists carefully monitor ocean oxygen levels around the world, because the ocean is not just a collection of separate environments. It is one enormous living system. Currents connect distant regions. Temperature changes influence circulation. Chemical changes spread through water over time. A problem that begins near one coastline can eventually affect much larger areas. Climate change adds another layer of complexity. Warmer oceans hold less dissolved oxygen. As water temperatures rise, some regions may become more vulnerable to oxygen loss. Changing weather patterns can also affect rainfall, river flows, and the amount of nutrients entering the sea. Scientists are still studying exactly how these factors will interact in the future, but one thing is clear. The balance of life on Earth depends on countless invisible systems working together. The oxygen in the ocean, the movement of currents, the chemistry of the atmosphere, the relationship between land and sea. Most of these processes happen quietly. We rarely notice them, until something changes. Perhaps that is why dead zones are so fascinating. They reveal something hidden. They show us that even a planet full of life can contain places where life struggles to exist. They remind us that Earth is not an endless source of resources. It is a complex system with limits. And those limits are often invisible until we cross them. For millions of years, nature created and maintained these balances without human interference. But today, humanity has become one of the most powerful forces shaping the planet. Our cities, our agriculture, our industries, our technology, all of these have transformed the world faster than any other species in Earth's history. The challenge is not stopping progress. The challenge is understanding the consequences of that progress. Because the same intelligence that allows us to explore the deepest oceans, to build machines that travel into space, and to uncover ancient mysteries, also gives us the ability to protect the systems that keep life possible. The story of dead zones is not only a warning, it is also a reminder of what we can still change. Rivers can be managed. Pollution can be reduced. Ecosystems can recover when given the opportunity. Nature is remarkably powerful, but it needs balance. And perhaps the greatest mystery is not why some places on Earth become impossible for life. The greatest mystery is how a planet filled with such extreme environments continues to support billions of living creatures every single day. From the deepest oceans, to the driest deserts, to the most hostile landscapes imaginable. Life keeps finding a way. But that ability should never be mistaken for invincibility, because Earth is not alive because it is indestructible. Earth is alive because countless fragile systems work together perfectly. And the moment we understand that, we begin to understand the greatest secret of all. The planet we call home is not just a place where life exists. It is a place where life is constantly balancing on the edge. And protecting that balance may be the most important discovery humanity ever made.